Alrighty, so in this video, let's take a look at an application problem with coordinate planes. We're going to go ahead and take a look at a fence that's being installed. It's going to be rectangular around a garden, okay? We're going to be growing some veggies and some herbs, so I don't know, maybe some basil, maybe some tomatoes, different things like that. I'm going to be planning out the installation of this by plotting it on a coordinate plane, just to kind of plan it out first before we kind of do this in real life here, okay? So we have some corners here. We have corner A, B, C, and D, so just take note of those. And then part A is going to say make an accurate sketch of the fence. So we're going to plot these points here. So let's go ahead and plot A first. So let's go ahead and do this together. Let's put A. I'm going to put these diagonal so they don't get in the way. So A is going to be over 5 to the right and up to 9. So right over here in quadrant 1. What about B? B is going to be at 5, 2. I'm going to put the B off to the side here so it's not in the way. Let's go to 5 to the right and then 2 up right there. For C, it's going to go ahead and start the origin. Let's go to the left 7 and let's go up 2 right over here. I'm going to put this on the side. And then D, we're going to go to, go to -7 as well, but then we're going to go all the way up to 9. And hopefully this makes sense because it does make a nice little rectangle here. So it says make an accurate sketch of the fence. So let's just go ahead and just connect each of these lines here. So we can see a fence would go between A and D. So the fence would go between C and D. And then we can see here that this would also go from B to C as well as A to B here. All right, so there's part A. We just went ahead and made an accurate sketch of this fence. Okay, the garden is going to go in the middle of it, and then would be the boundaries to kind of keep it safe and protected from maybe deer or something else. Okay, all right, cool. Next, it says for part B, let's go ahead and find the length of segment AB. That's going to be this length right over here using an absolute value expression. So we're either going to add or subtract absolute values. Because they're in the same quadrant, we're going to make sure we subtract them. So take a look at A and B here. Notice they're matchy numbers. They both have these 5, so don't use those ones. But these numbers, they're in the same quadrant. So we can find the length of AB. Go ahead and write it with me. Segment AB, use the notation, is going to be equal to the absolute value of the one that's further from 0 minus the absolute value of the number that is closer to 0. So let's do 9 minus 2 instead of 2 minus 9. If we go ahead and do that, then we just have the absolute value of each of these numbers, which just become positive, and 9 minus 2 is going to be 7. So we know that along this sketch here, this is going to be 7 units between A and B. You can also check it by going 1, 2, 3, 4, 5, 6, 7 if you're not sure, or if you think you might have made a mistake. All right, so there's part B, and that's the distance between A and B. All right, now we're going to do part C. Part C here says find the length of BC. Let's see, BC on our sketch here is between here and here. Ask yourself the question, are they in the same quadrant or different quadrants? They're in different quadrants, so if we look at their coordinate, the ordered pairs here, the coordinates, they have matching y values. We're going to add the absolute values of their non-matching numbers. So the 5 and -7. So let's see, we're doing B and C. We have, what did I say those numbers were? B and C. The non-matching numbers are 5 and -7. So I'm going to go ahead and write the absolute value of 5 plus the absolute value of -7. Doesn't matter which one comes first because we're adding. 5 plus 7, and that's going to be 12, right? So the distance between B and C on the coordinate plane is going to be 12 units away. All right. Next, we're going to have the distance between C and D. This one's kind of nice too, right? This one's not too bad because C and D, that's from here to here. That's actually going to be the same distance as A to B, but we just might have some different values here. So let's look at C and D. They have matching X's, so just look at their Y's, and they're in the same quadrant, so we're going to subtract. So actually it's going to look just like part B there, okay? So let's go ahead and do 9 minus 2 again. This one's going to be for CD though. Segment CD. Again, this should just kind of line up and check to be the same as what we had earlier. So the absolute value of 9 minus the absolute value of 2, that's going to be 9 minus 2, and that's going to be 7. So if we go ahead and write this down below, we should see that this does equal 7 units, which matches the length of AB. Let's see. Now we have we check these off as we go. We did C, we did D, Moving on to E. All right, for part E, let's go ahead and find the length of DA, which if we take a look at our diagram here, DA is going to be the same thing as BC. So when we check our answer, it should be the same thing. So let's see, DA is going to be this coordinate and this coordinate, or these ordered pairs. They have matching 9, so look at this 5 and -7. So we're going to take those, they're in different quadrants, 5 and -7. So segment DA is going to be the absolute value of 5 plus the absolute value of -7. That's really just the same thing as 5 plus 7, and that's going to be equal to 12. So we're looking at 12 units. We can go ahead and write that down here, and we can see this does match what we had earlier, so we know we did a good job there. Okay, all right, let's go ahead and try some additional problems here. So we just took care of E. And go ahead and just check that off so I know we did it. And then let's take a look at F here on the other side. So for F, we're saying what if 1 unit is 3.5 meters in real life? Okay, so then we want to find AB in meters. So let's just kind of flip back or look at what we said for AB. We said AB was 7 units, right? So let's go ahead and write that down. Segment AB is going to be 7 units, or we're going to write 7U. But we're going to try to turn this into meters. So each of these units is going to be 3.5 meters. We're going to multiply this by 3.5 to turn this into meters. So we're going to do some work on the side here. Let's see, I'm going to write it on the side and write just 7 over 1 multiplied by, and then if you go ahead and do big bottom plus the top, 7 times 2 is, 3 times 2 is 6. 6 plus 1 is going to be 7. This is going to be 7 over 2. All right, if we go ahead and multiply, we can't cross-cancel anything. 7 times 7 is 49. 2 times 1 is going to be 2. So we have 49 over 2. Now, what is this as a mixed number? Well, if you take 49 and you divide it by 2, it's going to go in 2 times. That's going to be 4. The remainder is 0. Go ahead and bring down the 9. 2 into 9 is going to be 4. 4 times 2 is 8. 9 minus 8 is 1. So we're really looking at 24.5 here. Okay, so in terms of meters, we're going to say this is going to be 24.5, and this is going to be meters here. So I'm going to put an M for meters. So that's going to be the length of AB in real life here of this garden, right? So that hopefully makes sense and wasn't too bad. But again, if 1 unit represents 3.5 meters, if we have 7 of them, we should multiply the 3.5 by 7. Now, keep in mind, what did we say AB is the same thing as? So I think it would be nice to kind of just do another one at the same time here. So we said AB, let's look at our picture here. AB was the same as DC or CD. So where do we have CD? I think we have another one here. Looks like it's going to be, part H here, right? And so what we can do for CD, we can just do this one right away, is we know this is going to be, what was the length of CD? It was 7 units. So go ahead and write 7 units. And don't redo the calculations, all right? Just go ahead and write in the work of how to get it, but then we don't have to write in everything else. So let's go ahead and just multiply this. We said it was 24.5, and that's going to be in meters. So we can just go ahead and write this is going to be 24.5. So don't redo anything. We just know it's going to be the same, so just show how we knew how to get there. All right, let's take a look at letter G. For letter G, we're talking about segment BC, and we want to figure out what it is in meters. So where's BC? BC we know is 12. Okay, so take a look at there. And if we know it's 12, let's go ahead and write, okay, BC is 12 units. But we're going to multiply this by 3.5. So 3.5. This one we haven't done yet, so we're going to write out the calculations for it. So how do you write 12? Well, 12 is just 12 over 1. And 3.5, if you go ahead and do big bottom plus the top, we said earlier was 7 over 2. So don't feel like you have to redo that one either. And then if you go ahead and multiply here, 7 times 12 is 84. And then 1 times 2 is going to be 2. And then if you go ahead and divide this, I'll go ahead and write the long division out in case it helps. But if you also want to pause and just do the calculation on your own, feel free to do so. That's going to be 4 times 2 is 8. 8 minus 8 is 0. Bring down the 4. 2 times 2 is going to be 4. The remainder here is 0. So this is going to be 42 here. So turns out it's a whole number, so it's going to be 42 meters. So we can write 42 meters for segment BC, and that's going to be how long the fence actually is in real life. We have another one over here, which is DA. DA, I think we can say, is the same thing as BC. It's the other last side of this. So if we want to say for DA, This one goes a little quicker because we already did one. This is going to be 12 units, and it's again multiplied by the 3.5 meters. Okay. And again, don't feel like you have to rewrite all the calculations unless you wanted some extra practice, but we know it's going to be 42. So hopefully if we did it right earlier, it's also going to be right over here. So now I's done, G's done, and H is done. All right. I think we just have 1 or 2 more things to do here. We have to do the perimeter in units, then the perimeter in meters. Okay, so let's do the perimeter in units first. So the perimeter, remember, is going to be 2 times the length plus 2 times the width. That's the formula. So let's start with that. Now, let's see, what is the length of this rectangle in units? Well, I think we had one of the dimensions was just 7 in units, and the other dimension was 12 in units. So in units, we're going to have 2 of these 7s, and then we're going to have 2 of these 12s. It doesn't matter which one's the length and which one's the width. 2 times 7, that means it's 14 units that way, and 2 times 12 is 24, so it's 24 units on the other dimensions. And 14 plus 24 is going to be 38. So the perimeter, we're going to say, is going to be 38 units if we're just measuring it on the coordinate plane. But what if we're going to go ahead and do this for the real life in meters? Well, let's start with the same formula, okay? But what's the length here? Well, let's see what goes with the 7. The 7 we said in meters turned into 24.5. So let's go ahead and write times 24.5, 24.5, plus 2 of these widths. What did we say the width was? That was originally 12, but when we turned it into meters, it's now 42. So put in 42 here. Okay, now if we go ahead and double 24.5, if you double 24, that's 48, right? So we have 48, and if you double the half plus a half is a whole, so 48 plus 1 is going to be 49. So if you go ahead and multiply 2 times 24.5, you get 49. If you double 42, that's going to be 84, okay? Now if you go ahead and just add these two together, let's see, 49 plus 84, that's 13, carry the 1. That's 5 plus 8 is going to be 13. I think we're going to get 133. But remember, this is going to be measured in meters instead of being measured in units. Alrighty, so there we have the perimeter all done. Let's go ahead and check out the area. We're going to do the area in 2 different types of units. So area is going to be length times width. Let's do the units first. So I think we said it was, 7 and 12. So 7 times 12. That's going to be, I think, 84. So if you need to pause and do the multiplication, go ahead and do that. But the area here in square units is going to be 84 square units. What about if we're doing this in meters? Well, in meters, what was the length? I think we said it was 24.5. And then what about the width? The width, I think we said, was 42. So let's go ahead and write times by 42. And so if we go ahead and maybe do some work on the side here, 24 times 2 is 48, plus 1 is 49. So we're looking at 49 over 2, right? Multiplied by 42, which is just 42 over 1. All right, so if we're going to go ahead and multiply this out, we're going to maybe just multiply the top numbers here, 49 times 42. So if you need to pause and do that, feel free to do 49 times 42. I'm going to do that on the side here, 49 times 42. That's going to be 18, carry the 1. That's 8 plus 1 is 9. Put a placeholder, 4 times 9 is 36, carry the 3. And then 4 times 4 is 16, plus the 3 is going to be 19. If you add these together, we're going to get 8. We're going to get 15, carry the 1, 0, 1, and then 2. So I think we're looking at 49, what is that? 49 times this 42 is 2058. I think that's right. So this is going to be 2058 over 2. Oh, I can rewrite that too, a little nicer. And then I think we can divide this by 2 because it's an even number, right? So if we go ahead and take this 2058, let's go ahead and practice and divide this by 2. We're almost there. That's 1 times 2 is going to be 2. Subtract is 0, bring this 0 down. 2 goes into nothing 0 times. 0 times 2 is 0. We're left with 0. Bring down the 5. 2 into 5 2 times, that's going to be 4, left with a 1, bring down to 8. And again, if this is going a little quick, just pause the video and do it on your own, and then you can unpause and then see how you did. So 9 times 2 is going to be 18, and you're going to get 0 here. So the area in square meters is going to be 1,029 square meters. All right, cool. So there you have a few different practice problems dealing with an application of a coordinate plane where we dealt with some area and perimeter, specifically looking at a rectangular garden. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep with the great work that you're already doing.